See, for all those who are new and for the rest of you, we had started with this unit electrostatics. In this, we have started with electric field and charges. So see, under electric field and charges, we were discussing electric charge. So methods of charging we are already over with. In methods of charging, it basically means the transfer of charge, how electrons get removed, and the body that gains electrons becomes negatively charged, and the body that loses electrons, it becomes positively charged. So there were basically three methods of charging. One was charging by friction, other one was charging by conduction, and the third one was charging by induction. But today we'll begin with Coulomb's law, so this much is not required, but we were discussing properties of charge. So you can continue from here. Properties of charge you will be able to understand. See, electric charge, this is the basic or intrinsic property of matter that gives rise to various phenomena like electric forces, electric field. These occur only because of such intrinsic properties like electric charge. So you cannot define electric charge. With the help of electric charge, you are able to define other phenomena like electric force. So electric force we'll see in detail in today's class. Okay, so properties of charge. The first property of charge includes additive nature of charge. Additive nature of charge means that if you have n number of charges with you and you are required to calculate the net charge, so what you do, you take out the algebraic sum of it. For example, if it is plus 2 coulombs, here it is plus 3 coulomb, here it is minus 1 coulomb and minus 2 coulomb. So you don't need to consider any sign because electric charge, this is a scalar quantity and it does not have any directions. So just simply add it and you get 2 coulomb. So this 2 coulomb, this is the resultant. This is the net charge present in this system. So it means charges allow themselves to add algebraically. Algebraically, why? Because these are scalar quantities. Then we had seen charges are conservative. It means electrons do get transferred from one body to another, but transfer of protons doesn't occur. Transfer of proton does not occur. Why? Anyone who were there? Fatima, you were there.
Because protons are inside the nucleus.
Yes. So see, basically what happens, protons are inside the nucleus and nuclear force, this is 100 times stronger than the electric force. So that's why the nuclear force doesn't allow the protons to move out, whereas electrons are held through electric forces, and electric forces are weaker as compared to the nuclear forces. So this allows the electrons to get transferred. So whenever we say we have a positively charged body, this doesn't mean that a body has gained protons, so that's why it has become positively charged. This simply means that the body has lost electrons. That's why we say charge is conservative. Means if a charge has transferred from one body to another body, so we say the charge has transferred only. The body has not created the charge. The body that is negatively charged, the body has not created any charge. Or the body that is positively charged, it hasn't destroyed its charge. It's just that transfer of charge occurs. Third property was invariance of charge. Invariance of charge means that charge is independent of speed of the body. Like the example I gave you, if a body is, this is a body, it is traveling with 3 meters per second. The charge present on it is 4 coulomb. The speed increases to 5 meters per second. So it is not necessary that the charge will also increase because of increment in the speed. If the speed has increased from 3 meters per second to 5 meters per second, it doesn't matter to the charge. Charge is independent of the speed. So the charge on this body, after the increment in the speed, it will still be 4 coulombs only. Then the last property, which is one of the very important properties, from this quantization of charge, your numericals also come. So quantization of charge basically means that minimum charge possible in one electron. This is 1.6 into 10 to the power minus 19 coulomb, this number. So all of you should remember this. 1.6 into 10 to the power minus 19 coulomb. This is the minimum charge possible on a single electron. So if you have 1 electron, this is the minimum charge possible. If you have 2 electrons, so double it will be 3.2 into 10 to the power minus 19. If you have 3 electrons, triple it, It will be 4.8 into 10 to the power minus 19. So only these values are possible. Means integral values of 1.6 into 10 to the power minus 19. If I give you 100 electrons with me and I want you to calculate what is the number of charges present on these 100 electrons, so what you will do, you will simply multiply 100 with this number, because this is the minimum number possible of electric charge, and you have 100 electrons with you, so you multiply it with. Similarly, if you had two charges, you just doubled it, whatever is the charge present on a single electron. So this property that Q is equal to Ne means this number of electrons, and this is the electronic charge, which is 1.6 into 10 to the power minus 19. This is known as quantization of charge. Means charges, these are integral multiple of 1.6 into 10 to the power minus 19. So all observable charges in nature are integral multiple of 1.6 into 10 to the power minus 19 Coulomb, and all of you should remember this value, 1.6 into 10 to the power minus 19 Coulomb. So is there any doubt till here? All those who were present in the previous class. Should we move further then?
Yes, ma'am.
All right. Regarding the assignments also, only Krishna has submitted from this batch. Yes, Krishna, only Krishna has submitted. Others also, please submit your assignments, and if you're having any doubts from your assignment, you can ask me the question. Okay. Just try this question. Calculate number of electrons corresponding to 1 Coulomb. Now see how you have to calculate. You have to find out the number of electrons corresponding to 1 Coulomb. Means Q is equal to Ne. This is the formula that you have. This is the first formula of your chapter. So, and this is required, and questions do come from this formula. So see, Q, what is the charge present? Charge is given to you. Can any one of you tell me what is the charge present?
1 Coulomb.
1 Coulomb.
1 Coulomb. The charge is 1 Coulomb. Number of electrons, we don't know what is the number of electrons. We have to calculate the number of electrons. And E, Heba, you tell me what is E? Yes, Heba.
Teacher, can I say?
Okay, Fatima, you tell.
1.6 into 10 power minus 19.
Correct. 1.6 into 10 to the power minus 19. See, this is the electronic charge. By this symbol E represents the electronic charge. Electronic charge means the minimum charge present in a single electron. One electron has 1.6 into 10 to the power minus 19 coulombs. This much charge is present in a single electron. All right, now only one variable is there. Just calculate fast and tell me. Write me your answers in the chat box. All those who are new will also be able to answer it. Tell me what is the number of electrons coming. Fatima, is this your number of electrons coming? Just check once again. So Kulsum is right. Akifa is right. Krishna, there's some error in your power of tens. Just check it once again. Yes, Fatima Munir is also right. Yes, Krishna, now it's correct. Others also, you just have to simply divide it. You have 1 coulomb with you on the left hand side and 1.6 into 10 to the power minus 19 on the right hand side. You just have to divide these two quantities. Hafsa, Hiba, you also answer. All right, see. So see, number of electrons were missing. You have the electronic charge and you have the value of charge with you. So N will be equal to Q divided by electronic charge. Means 1 divided by 1.6 into 10 to the power minus 19. And when you divide it using simple division, you get 6.25 into 10 to the power 18. This is the number of electrons present in a single coulomb of charge. So see, what you do, one thing, just remember this value as well, 6.25 into 10 to the power 18, because many a times in the question it comes 1 divided by 1.6 into 10 to the power minus 19. So instead of wasting your whole time in calculating or dividing, just remember this value, only this value, not for 2 coulomb or 3 coulomb or any other value. For 1 electron, remember 1.6 into 10 to the power minus 19. And for 1 coulomb, remember 6.25 into 10 to the power 18 electrons. This will ease your calculation. So all those who have not written, just quickly write it down. For others, I am giving you one more question. Last question we'll do, then we'll begin with Coulomb's law. So all those who are done with this question, just try this once. This involves a bit of your chemistry, what you have done in your 11th. So you have to calculate number of electrons in 1 glass of water. Now see, 1 glass of water, this is roughly taken as 250 centimeter cube only. So volume is given to you as 250 centimeter cube only. So hint for all those who are trying this question, first try to calculate the mass. You are given volume, you know the density of water. So try to find out its mass. Using mass, you can find out number of moles. So chemistry is required. The mole concept chapter 1 of standard 11th. Just try this one. Take 2 minutes, then we'll discuss it. Let's discuss it then. This is a long question. See, volume is 250 centimeter cube. This is volume given to you. So if volume is 250 centimeter cube, yes, Akifa, you tell me, what is the density of water? We have done it together only.
1000 kilograms per meter cube.
And in CGS, this 1000 is kg per meter cube. In CGS, anyone? CGS unit of water?
1.
1, right? It's 1. This is 1 gram per centimeter cube. In CGS, the density of water is 1 gram per centimeter cube. In SI unit, it is 1000 kg per meter cube. Now see, density is equal to mass by volume. So mass will be what? Density multiplied by volume. So mass of water will be what? 250 multiplied by 1. That gives you 250 grams again. Now you have mass of water as 250 grams. What is the molar mass of water? Recall your chemistry. What is the molar mass of water? Yes, molar mass.
18.
18. Molar mass of water, this is 18 grams. So if you are required to calculate number of moles in 250 gram, so number of moles is calculated using by taking the ratio of the given mass by the molar mass, GMM, what you say in chemistry. So mass is 250 and molar mass is 18. This much moles are present in 250 grams. Why did we take moles? You will understand. Because we have to calculate number of molecules, number of electrons in order to find out the charge. So see, number of molecules in 1 mole. Yes. What is the number of molecules present in 1 mole?
Avogadro's number.
Avogadro's number, correct. This is 6.023 into 10 to the power 23, Avogadro's number. So number of molecules present in 1 mole is this. Now if I tell you what is the number of molecules present in this much moles, you will simply multiply it with this. So number of molecules in 250 by 18 moles. This will be 6.023 into 10 to the power 23 multiplied by 250 by 18. Just tell me, is it clear till here?
Yes.
Yes, ma'am.
Okay. See, when you multiply this, I remember this answer, so I'm writing it down. After the class, you can try. You will get it 8.3 into 10 to the power 23 molecules. So see, this is 1 glass of water has 8.3 into 10 to the power 23 molecules. Now see, we require not all the molecules, we require only electrons. Electrons, H2O is water. So number of electrons present in oxygen is 8, and for each hydrogen atom you have 1. So total number of electrons present in water, number of electrons, this becomes 8 for oxygen plus 1 for this hydrogen plus 1 for the other hydrogen. 10 electrons. Yes, 10 electrons are there in a single molecule of water, H2O. That's how you calculate. Now you have number of electrons. See, you have to calculate the number of electrons in this much molecules. Means you have to calculate the number of electrons in 1 glass of water. And 1 glass of water is having how many molecules? 8.3 into 10 to the power 23 molecules. So if you have to calculate number of electrons in 8.3 into 10 to the power 23 molecules, means 1 glass of water, number of electrons in 1 glass of water. That will simply be 8.3 into 10 to the power 23 multiplied by 10. A single molecule of water has 10 electrons. So 8.3 into 10 to the power 23 molecules will have how much? Multiply it. That's how you do using unitary method. Now you have number of electrons present. You can even write it 8.3 into 10 to the power 24 electrons. So this becomes your N. You have N now. What we were required to calculate, we had to find out the charge. We were not aware of number of electrons. So that's why we had used this procedure and utilized a bit knowledge of chemistry to calculate number of electrons present. Now you have number of electrons present with you. You in this formula, N is there, E you already know. Now calculation of Q will be easier. N is 8.3 into 10 to the power 24. Electronic charge is 1.6 into 10 to the power minus 19. So this much coulombs of charge will be your answer. Tell me, is it clear or anyone is having any doubts? You can even text me if you are having any doubts. If you are unable to unmute yourself, if you are not comfortable, you can text me also in the chat box. So I hope this question is clear. Just note it down. Wherever you get stuck, just ask me. Just write to me whenever you are done. You have completed it. Okay, so most of you have completed. If anybody is still writing, you can stop me. Otherwise, I'm moving ahead. So see, this was your introductory part, which included electric charge. And in this, quantization of charge was important. Also, this question, which we did just now, this was of your NCRT only. Now see, let's move to Coulomb's law. See what is meant by Coulomb's law. If I say I have a single charge present with me, Q1 is a charge present. I bring another charge plus Q2 as well. And I say both of these charges, these are separated by some distance smaller. So there are two charges present. Q1 and Q2 is present. Both of these charges, these are separated by some amount, which I say let it be smaller. Now see, according to Coulomb's law, understand what is meant by this Coulomb's law. The electrostatic force that will be generated between these two charges. See, force comes due to interaction, and because of force, we get potential energy. So, not focusing on potential energy, just focusing on force only. If you have two charges with you, and these two charges are separated by some amount, this was small r. So, the electrostatic force of attraction or repulsion present between these two charges. Electric force between 2 point charges. This is proportional to two things. Remember, two things it is proportional to. The first one, it is electric force is directly proportional to the product of the magnitude of both the charges. Product of magnitude means what? If I have Q1 with me, so I will take Q1, whatever is the magnitude of Q1, and I have the other charge as Q2, so Q1 multiplied by Q2. So electric force is proportional to the product of magnitude of both these charges. What does this mean again? If I say I have a charge as -4 Coulomb, other charge as, let's say, +2 Coulomb. So electric force will be proportional to, take the magnitude of the first charge. What will be the magnitude of the first charge? -4.
Yes.
Minus sign won't come, Krishna. See, minus means it is not the magnitude. Magnitude means you do not consider the sign, whether it is positive, whether it is negative. You are just concerned with the number. Number means magnitude. Even in the starting of your 11th class, you must have done. For example, if you have 4 Newton, Newton is the SI unit. This is the SI unit. 4 is its magnitude. If you have plus minus sign over here, +4 or -4, it doesn't mean that this is the magnitude. Magnitude means the number without the sign. So if you are considering the electric forces and you have to take the charges, you won't take -4, you will simply take 4. So had it been -4 or had it been +4, you would have only taken 4. So 4 multiplied by, again +2, so you take 2. So electric force will be directly proportional to 8 Coulomb. Is the first point of Coulomb's law clear? How do you take the charges?
Yes, ma'am.
Now, second point, electric force, this is also proportional to one more thing, that is, it is inversely proportional to the square of the separation between them. Square of the separation between them. If I say both these charges were separated by 3 meters, then this force was inversely proportional to square of the separation between these two charges, means 3 square. So force was inversely proportional to 1/9. This is what is meant by Coulomb's law. These are the two statements of Coulomb's law. That if two charges are there in nature which are separated by a certain distance, electric force between these two charges is given by the electric force is proportional to magnitude of both these charges, and it is inversely proportional to the square of distance between them. This is what your Coulomb's law is. This is a law only that will be required to solve rest of the phenomena and your questions. See, if I say F is directly proportional to Q1, Q2 and inversely proportional to R square, for deriving the formula, I have to remove this proportionality sign. So see, in mathematics, what you do, whenever you have to remove this proportionality sign, you just write equal to with a constant. That's how you remove proportionality sign in mathematics. So force will be, proportionality sign has been removed, K Q1 Q2 divided by R square. This is your Coulomb's law. This is your Coulomb's law. We'll focus it, what is this K? What are the constituents of this K? But for the time being, just remember this K. K is equal to 1 divided by 4 pi epsilon naught. This symbol, see this symbol, this curved E, this is known as epsilon. So you put a 0 in the subscript just to represent that we are considering the force of vacuum. So we will study this because this is new to you. Just remember, so this becomes epsilon naught. 4, you know, it's a constant number. Pi, you all are already aware of 3.14. So 1 divided by 4 pi epsilon naught. This is known as K. K is also called as the dielectric constant. Dielectric constant will be used a lot in your second chapter, potential and capacitance chapter. By that time, remember, the value of K is 1 by 4 pi epsilon naught. So you can write force as Q1 Q2 by 1 over 4 pi epsilon naught R square. Now see, this symbol is known as epsilon, and because we add a 0 in the subscript, it becomes epsilon naught. But this actually, the symbol, this is the absolute permittivity. This is the absolute permittivity. So we will do this till the time, just note these down. Just note it down. We'll come to what is K, what is the constant. All right, let's see what is this absolute permittivity is. Let's just expand on this constant that we have. This is the dielectric constant K, and epsilon is the absolute permittivity. When you add this epsilon naught, this just signifies that this is the absolute permittivity of air or vacuum. Basically, this is free space, permittivity of free space. This is known as absolute permittivity of free space. One more thing that you have to remember before moving into the details, that absolute permittivity of free space means this quantity for air, the value is 8.85 into 10 to the power minus 12 Coulomb square. This will be Coulomb square per Newton per meter square. So 8 point, again, this also you have to remember. One more thing that you will be remembering is, now see, if I have given you the value of permittivity of free space, means you have this value. You know what is 4, you know what is pi. So can we get the value of K? Is it possible for us to calculate the value of K by ourselves?
Yes.
Yes? So see, when you will write all these value in this K, 1 by 4, then pi as 3.14, epsilon naught as 8.85 into 10 to the power minus 12, you get it as 9 into 10 to the power 9 Newton meter square per Coulomb square. So this is the value of K that you have. Now see, if you have this formula, F is equal to K Q1 Q2 divided by R square. So if you know the magnitude of both the charges, you know the separation between the two charges, then you can easily calculate electric force. Just substitute 9 into 10 to the power 9 for K. For instead of writing the value of K, you can write 9 into 10 to the power 9. Now let's see what is this dielectric constant. And let us also see this also relative concept of relative permittivity. Concept of relative permittivity. Now see, dielectric constant or relative permittivity. If you have Q1, Q2, both of these are separated by some distance r. Let's say this is in free space. So I write down the value of electric force in air as Q1, Q2 by 4 pi epsilon naught r square. This is how I'll be writing electric force using Coulomb's law if two charges are present in the free space. Now see, what if I change the medium? Instead of writing everything in free space, I take a different medium with me and I place these charges instead of air. Now I put these charges in that respective medium. So let's say Q1, Q2 was the charge present, the separation was R. Now the force present in this medium, this will be Q1, Q2 divided by 4 pi epsilon R square. You won't write epsilon naught. Epsilon naught is specifically for free space. Free space means air or vacuum, for which the value was 8.85 into 10 to the power minus 12. Epsilon you are writing for any medium that you have. Now tell me, if I write the value as different, so my force will be the same or the force will also be different?
Different.
Different. If I change the denominator, obviously the whole fraction will also get disturbed. So this means this quantity, permittivity, this actually governs the dependency of force. I'll write down this also. It governs the dependency of force on a medium. What does this mean? This means that if whatever or by however ways this force is related to that medium, we can easily identify through this epsilon. Means this permittivity. It tells us how is the force dependent on that medium. For example, if I have a particular medium 1 and the value for that medium 1 is something of epsilon, if I change the medium to medium 2, then epsilon value will also change. So by this, we will come to know that the medium has changed because of the change in the force. That is what is meant by permittivity. For free space or air, you have a specific value for what you have to remember. For rest of the medium or for any other medium, you don't have to remember. That will be given in the question if it is asked. More or less, what we do, we convert any medium into air only because we remember it for air. So we can calculate it for air. See how we can calculate it for air. There is one relation. Epsilon means permittivity of any medium present, divided by epsilon naught means permittivity of free space. Their ratio is also called sometimes as relative permittivity. So this was absolute permittivity of any medium. This is absolute permittivity of free space. So the ratio gives us relative permittivity of medium, whatever is the medium. Now see, this relation also includes the ratio of epsilon by epsilon naught includes this K. This is the dielectric constant that we are talking. What are the properties of dielectric constant? How this dielectric constant is physically used, that we'll see when we'll do potential. But for now, you should remember that the ratio of epsilon by epsilon naught is K. So if I have to substitute epsilon, I can write it as the product of epsilon naught and K. So whenever, what we mostly do if we are given different medium, where we have the force in the medium as Q1, Q2 by 4 pi epsilon r square. And we don't know what is epsilon. Had it been epsilon naught, then we would have known the value of epsilon naught as 8.85 into 10 to the power minus 12. But here it epsilon is given. So what we can do? We can use this relation epsilon is equal to epsilon naught multiplied by K. So F medium will be what? Q1, Q2 divided by 4 pi epsilon naught K. Instead of epsilon, I have written epsilon naught multiplied by K divided by this R square. One more relation also you can establish. Can any one of you tell me what is this Q1, Q2 by 4 pi epsilon naught R square? Just ignore this K, leave this K and look all the quantities that are present. Just ignore this K. What is left then?
Force
Force in
Force
between
in
the
free
two
space.
charges.
in freeze. Exactly. Now you are correct. Force in the air. This is what is left. So force in air divided by K is only this quantity, no? So if you are given a force in any medium, you can divide it by K and get the value. Or if you have a force in any medium, you know the dielectric constant multiplied, that will give you the force in air. So this is one of the relation that is used, and from this relation also you can establish this fact that if K is greater or equal to 1, your force in air will also be greater than force in the medium. Is this clear? Concept of permittivity. We'll do questions on this Coulomb's law. Clear to all of you? Any doubts?
Yes, ma'am. Clear.
So just note down this part as well, then we'll do questions on it. One more thing, if your K is equal to 1, then F will directly be equal to Q1, Q2 by R square. That you will manage. So from here you have to write, no? Just write it down. Wherever you want me to repeat any part, just let me know. Completed. All right, I think by now all of you must have completed. Anybody is writing, can text me. I'll stop. All right, before we move on to the numericals, let's just do few properties of this. Properties of Coulomb's law. We have done properties of electric charge. Now those properties were independently for those electric charges. Now we are writing properties which are valid for this Coulomb's law. So the first property is that it is valid for point charges. Also, in nature, when you are given point charges, if you have spheres also, then that can also work as point charges. So point charges or spheres. So if you have a sphere with you with charge Q1 and Q2, both these can exert Coulomb's law of force. Or if you have 2 point charges Q1 and Q2, both of these can use Coulomb's law. The second property is that it is valid if the charges are static. We are already studying electrostatics, so we are not involving phenomena like velocities or acceleration of charge, because for us the charge is at rest. The charge will be in motion. We will be studying current, electricity, and effects of magnetism and all. Right now, this says that for Coulomb's law, it is valid only if both the charges are static. So both the charges are static means both the charges should be at rest. Or one more thing is also valid. Even if a single charge is at rest out of both the two charges, then Coulomb's law can still be applied. But if both the charges are moving, then Coulomb's law is not applied. So one more thing that is valid is if both the charges are static or at least one of them is static. Or at least one of them is static. This is when Coulomb's law is valid. Also, when one of them is static means the other one is moving. So distance should not change between the two charges. It should not happen that the charge that is moving is shifting in the distance. So distance between them does not change. This is what is meant by one of them is static. Like if I give you a very small example in this. If this is a charge plus Q1, this is a charge plus Q1 and another plus charge Q is there, which is not static. This one is static. This is not static. It is moving around this charge in a circle, covering a circular motion. So the radius of the circle should remain fixed. Circle's radius will remain fixed. Q2 will be moving. Q1 will remain in static. This will apply Coulomb's law. So in such a situation, you will be able to use Coulomb's law. Or rest situation is when both the charges are static and there is separation between these two charges. So this is the second property of Coulomb's law, which says that both the charges should be at rest. Either both the charges should be at rest or at least one of these two charges should be at rest. The third property, it is a conservative force. So conservative forces, non-conservative forces you have done in 11th standard. Can any of you tell me what is meant by conservative force? Conservative force, non-conservative force, you must have done in 11th standard. Work, energy, and power. See, in case of conservative forces, the work done is independent of the path traveled. It just depends on the initial and the final position. That is what is meant by a conservative force. So Coulomb's law is also one of those forces. Also, one more thing, it is a central force. Central force means that it acts along the line joining its center. Means if these are the two charges, then it acts along this line joining its center. Means it doesn't mean that if Q1 is a charge, both of these charges are there. So because this is a positive charge, this will be pushed away because of electric force. So electric force will act only in this direction. It doesn't mean that if these two charges are present and this is exerting a force on this charge, so force will act in this direction. It will act on the line joining its center. If you remember and if you are able to recall your gravitational force, that was F is equal to capital G M1 M2 divided by R square. This is similar to it only. Both these laws are universal laws where both of them follow inverse square rule. In gravitation also you have studied gravitational force is inversely proportional to square of separation between the two masses. Here instead of masses you have charges. So electric force is inversely proportional to square of the electric charge between these two. Is this clear?
Yes, ma'am.
Okay, do one thing, write down these properties. Also, I'm giving you a very small and a very easy question. All of you should answer me. All of you will write me in the chat box. Till the time, just note down these properties. We'll do a very easy question, formula-based question. Everybody should answer. All of you try this question. It's a very easy formula-based question. Meanwhile, Z,
Yes.
Z, we had started with Coulomb's law. We have completed the properties of charges that we were doing in the last class. Now we are doing Coulomb's law. So Coulomb's law, basically just brief yourself, then you can see the lecture in detail after the class. if you have two charges present. Okay. Till the time Zaid is listening, rest of you try the question and send me your answers. So if you have a charge present with you, Q1 is a charge, Q2 is another charge present. And both of these charges are separated by a certain distance between them. So electric force, this is directly proportional to product of magnitude of these charges, means Q1, Q2, and inversely proportional to square of separation between them.
Yeah.
All right. So just try this question if you are already aware of this law and if you are able to calculate. Otherwise, if you need help, can ask me.
Ma'am, what should we put like in the place of K? Should we 8.85 or 9 to 10 to
9 into 10 to the power 9. See, K is always 9 into 10 to the power 9. Epsilon naught is 8.85 into 10 to the power minus 12. And this is also valid only for air. For different media, it gets changed.
Okay. Ma'am, is it minus 6 10 raised to power 9?
See, you don't have to take the sign. Even if it is given minus 3 millicoulomb, you have to take 3 only. That is what I was saying. Electric force is proportional to product of magnitude of the two charges. So whatever is the sign, you have to ignore the sign. You just take out whatever is the magnitude. All right, so your force won't come in plus or minus. It will always come in positive because you are taking the magnitude. And yes, your magnitude is correct. Rest of you also submit your answers. This is a direct formula-based question. Akifa, there is error in your power of tens. Just check it once again. And all of you do convert these values of Q1, Q2, and R in terms of SI unit. These are not given in SI unit. One is in microcoulomb, other is millicoulomb, one is in millimeters. Rest of you also answer. Only Kulsum, Akifa, and Zaid have answered. Fatima, Munir, Fatima, Hafsa, Hamza, Hiba. Krishna, you also answer. Q1 is given to you. This is Q2. This is separation R. Take K as 9 into 10 to the power 9. So only 3 students have answered, Akifa, Kulsum and Zaid. Now see, Coulomb's law. If you have to calculate the electric force between these two charges, it is not given that they are in motion. They have a certain separation between them and two charges are present. So all the properties of Coulomb's law is valid and you can use Coulomb's law. So electric force, this is equal to K Q1 Q2 divided by R square. Yes, Krishna. Krishna is right. Correct answer, Krishna. So we have to find out value of each. Hamza, you tell me, what is the value of Q1?
Ma'am, +2.
Only 2? Can I write this? Is this fine? Is it in SI unit, Hamza?
No, ma'am.
So how do I convert it into SI unit? Just try it yourself, otherwise we'll help you. See, 2 microcoulomb. 1 microcoulomb is 10 into 10 to the power minus 6. So Q1 becomes 2 microcoulomb, it becomes 2 into 10 to the power minus 6 coulomb. This is your first charge. Again Q2, Hamza, you tell me, what will be Q2?
-3 into 10 to the power -6 Coulomb.
No, see, minus you won't take because you are considering the electric forces. Okay, so when you are applying Coulomb's law, don't take the magnitude of charge. Means you do not have to take -3 or +3, +2 or -2. Even if it's given -3, let it given as -3. You just have to take 3 only. Okay, now see, this is millicoulomb's law. Now this is millicoulombs. Earlier it was 2 microcoulomb. So Hamza, remember one thing, 1 microcoulomb is 10 to the power minus 6 coulomb. Whenever you have to convert micro, just write 10 to the power minus 6, it will be converted into the SI form. Also one more thing, remember, when you have 1 millicoulomb, whenever you have to replace milli, you have to divide the quantity by 1000. Means you have to multiply it by 10 to the power minus 3. Hamza, tell me, is this clear? Conversions?
Yes, ma'am.
So tell me, if it is 3 millicoulomb, how would I write it?
3 into 10 to the power -3.
Correct. Okay, so this is how you convert. This will be 3 into 10 to the power minus 3 coulomb. So Q1 is in micro, so that's why we have converted, and Q2 was in milli, so we have converted. Also separation. Yes, Fatima, Munir will tell me. What is the separation between these two charges? What should I write? R. Yes, Fatima, Munir. Are you there in the class, Fatima? At least write a yes or no, then I'll know that you are present in the class. All right. See, Fatima, separation between the two charges. You can even write to me, what is the separation between these two charges? Just look the first charge, plus 2 microcoulomb. Look at the second charge, minus 3 millicoulombs. With what separation are they present? Hafsa, what is the separation between the two charges?
Three millimeter.
3 millimeters. So how do I write it in SI units?
3 into 10 raised to minus 6.
-3. See, milli. Okay, had it been micro, then I would have used 10 to the power -6. Whenever it is given mm in form, milli form, then you write 10 to the power -3. So this is also 3 into 10 to the power -3 coulombs. And value of this K is this constant, 9 into 10 to the power 9. K is basically your 1 over 4 pi epsilon naught that we are studying. Now we just have to put in the values. K is 9 into 10 to the power 9. Q1 was 2 into 10 to the power -6. Q2 is 3 into 10 to the power -3 divided by R square. So 3 into 10 to the power -3 is whole square. This is what we have to calculate. So 1 whole square will get cancelled by this 3 into 10 to the power -3. For the rest one, we have 3 multiplied by 3, that gives us 9. And 3 multiplied by 2 gives us 6. So F is equal to 6 multiplied by 10 to the power 9 multiplied by 10 to the power -6. 9 minus 6, this gives you 10 to the power this gives you 10 to the power 3 with this 10 to the power -3 in the numerator. So force is equal to 6 into 10 to the power 6 Newton. Very easy question based on the application of Coulomb's law. Just write down all of you who have not written and try one more question. And remember the conversions whenever it is given micro or whenever it is given milli. So with passage of questions, we will discuss the rest of the units also. So for all those who have written, you can start copying the other question and try it. This is also an easy question only. Q1, Q2 with separation R has the force F. What will be the force if magnitude of the charges is doubled and the separation is half? So first write F is equal to K Q1 Q2 by R squared. That will give you for the first part. For the second part, don't take it as Q1. Take it as 2Q1 and take it as 2Q2 for the double of the magnitude. And instead of R, take it as R by 2 because the separation has been halved. Don't take the force F again. Now the force won't be F. So you have to take it as F prime, F dash, or F not any other force, and see how is F related to the new force that you have calculated.
Then should we include K?
You can include K will get cancelled because K is in same for both of them. For the first part also, second part also. So include K and then C. When you take the ratio, K will also automatically get cancelled. See, two charges Q1, Q2, these are separated by a distance small r, repel each other with a force F. So on applying Coulomb's law, this will be K Q1 Q2 divided by R square. This is simple. This is the first part of the question. The second part says the magnitude of each of the charge has been doubled. So it won't be 2Q1 now. It won't be Q1 now. You have to take it as 2Q1. You have to take it as 2Q2. And the separation between these two charges, this is not R. Since the separation has been divided by 2, it has been half. This will be R by 2. So you have to
Ma'am, is it,
calculate F dash.
should we like
Yes, sir.
if we are taking like distance R by 2, so we have to square R by 2 full or
Full,
only
full.
R?
No. R by 2 whole square.
Okay.
Yes, correct. Krishna has answered first. Correct answer, Krishna. Rest of you also try.
It's Q1 Q2 upon 4.
Yes, sir.
Q1 Q2 upon 4.
The answer.
Mm-hmm.
Q1, Q2 will also be cancelled. No. Q1, see, Z. See, this is the first part of the question. This is the second
Yeah.
part. So write whatever will be the force now because you won't take Q1, Q2 and then take the ratio. So Q1,
Okay, it's
Q2
coming
are
4 upon 4, so it is 1. Okay. It's 1.
1 is what?
It's the ratio of F2 upon F1.
Everything is getting cancelled. Nothing is left. Just check
Yeah.
once again. Something will be
Let me
left
check
there.
it.
Just check once again. Hamza, you also check. You are getting the same answer as Z. Something will be left. When you will square it. Yes, correct, Akifa. So, correct answers have been given by Krishna, Akifa. Rest of you also respond. Coulomb, Hiba, Hamza. Hamza has answered. Hafsa, you try. Fatima, both the Fatimas. Fatima Munir, Fatima. See, here it will be K. Instead of Q1, what should I take?
2Q1.
2Q1. So I will take 2Q1 multiplied by Q2. What should I take? 2Q2 divided by Now that I have to take
R by 2.
r by 2 whole square. See, what is r by 2 whole square? This is r square divided by 4. This is your r by 2 whole square. So f prime will be what? Is the answer, is there any improvement in the answer? Any different answer? Zaid, Hamza? Or is it still 1?
No, no. It's if we take 4 up, so it will
So,
be 8.
yes, it will be 8.
Yeah.
Only 1, 2 is there.
1, 2 is there. Okay. Then 2 was 8. Sorry. 4, 2 is 8.
Okay, okay.
Sorry. 4
See, Zaid, Kulsum,
16.
Kulsum, you are yes, Zaid. Now you are correct. It will be 16. No. See, 1, 2
Yes.
is here. 1, 2 is here. This makes 4. This 4 will go up. 4 multiplied by 4 will give you 16. So that will be 16f. Kulsum is also right. Hamza, it won't be 4f. See, you have to take 1 more 2 also. See, all of you who are getting confused. F prime will be, k will be there. Take this q1, take this q2 by r squared. Now see what is left. 2 multiplied by 2. This gives you 4. And what was left in the denominator? This 4. So r squared divided by 4. So 4 will go up only, no? Now see, this is 16. 4 into 4 is 16. K q1 q2 divided by r square. And what is k q1 q2 divided by r square? This is f only, no? So f prime will be 16. Instead of this, we have f, 16f. Clear to all of you? Any doubts? So write down this as well, the solution as well. And if you are having any doubts, just ask me. All those who didn't respond, did you understand? Fatima, I'm explaining again. See, Q1, Q2 are separated by a distance smaller. So I have written it as F is equal to K Q1, Q2 divided by R square. Now the charges magnitude have been doubled. So it will be 2Q1, it will be 2Q2. And the separation between these two charges have been halved. So it won't be R, it will be R by 2. The question is clear to you, Fatima?
Yes, teacher.
Okay. Now see, F will be K Q1 Q2 divided by R square. And when we will write F prime, means the other force that we have, this will be K 2Q1 2Q2 divided by not R square. This time it will be R by 2 whole square. Is it clear till here how I have written this?
Yes, teacher.
Okay. Now see the calculation part, how I have done the calculation part. F prime was K 2Q1 2Q2 divided by R by 2 whole square. So see, R by 2 whole square. This will be K. 2 multiplied by 2. What is there in the numerator? Fatima, you only
4.
tell me. 4. And what is there in the numerator else?
4Q1, Q2.
4Q1 Q2 divided by. So once you will square R by 2 whole square, it will be R square divided by 4.
Yes.
Now see, this 4 will go up.
Yes, teacher.
So this will be 4 into whole term. K 4 Q1 Q2 divided by R square. Now see, 4 multiplied by 4. This gives you what?
16.
16. 16, and what is left? K Q1 Q2 divided by R square. And K Q1 Q2 divided by R square, this only know was F that we started with. So F prime is 16F. Is it clear now?
Yes, teacher. Thank you.
Now, if you all have written, just tell me. write done to me. I'll know that you have written it. Okay, so most of you have done. Fine, you can leave the meeting. This is for today. Just revise Coulomb's law and we'll continue on day after tomorrow, Thursday.
Thank you, ma'am.
Thank you, ma'am.
Thank you, teacher.
Thank you, ma'am.
Okay.